And the other method is also very straightforward. I think when I mentioned that you're trying to estimate what would be, what if I didn't do the voltage reduction, the first thing came to a lot of people's mind is that it's similar to load forecasting, right? So I can use this regression-based method. Okay, basically, a lot of TT just use linear regression. It doesn't work very well in practice, but it's simple. You can make it more advanced, like using neural network, using LSTM, whatever, to do the regression. But the basic idea is that you use the normal voltage data, we call CVR off data, to do the training together with voltage and the temperature. Okay, you do the training. And then when you have the CVR on data, you try to do the comparison. How you do that? You have this trained regression model already, and you use the temperature of the voltage reduction period's temperature. You use that as an input into the regression model, and then it will give you, okay, a kind of estimate what if you haven't reduced the voltage. And then you have the measured consumption as well. So the difference between the two will give you the CVR factor. So anyway, so no matter what, it's trying to estimate, like I mentioned, this red dotted line, what it looks like. It's just trying to use different regression method or neural network to estimate that. So that's the regression-based method. So I can show you that how we do that briefly. So we actually only care about the substation level CVR factor because that's what utilities want to see. They don't care at each customer what's their CVR factor, right? So basically you try to calculate, okay, CVR off, estimate this using the regression, and this is coming from your measurements. And then you substitute into this equation, you will get the CVR factor. But what you will get is more like a real-time CVR factor. That means depending on your time resolution, if your resolution is hourly, that means you have 24 CVR factor for 1 day. So that doesn't make sense, right? Because your utility want to see one CVR factor for the whole year, maybe. So the things you can do is that try to calculate their energy consumption difference, and then you end up with one CVR factor, whether it's daily or monthly or yearly, it doesn't matter. It's more like doing some kind of integration. Okay, so this is a regression-based method, and we actually use LSTM to do the regression. So when we do the case study, so this is coming from real data from our utility partners. It's actually a rural co-op here in Iowa. And you can see that using that regression method, the real-time CVR factor distribution, and this maybe matter more, the daily CVR factor for one substation in the whole year. So how it looks like for different days. So it's not 365 days because they didn't apply CVR every day. Okay, they just select some days to apply CVR. So that's why you can see this. And you can see that the CVR factor is relatively small, around about 1%. And sometimes you see negative CVR factor. So that could happen depending on the load composition. So this is basically you're talking about a CVR factor from a little negative, you can assume this is 0 to about 1.5. That's the range for this substation.